Welcome friends, my name is Monikandan, a specialist in geography. Today we are going into the lecture of a very important topic taken from applied climatology. That means this is a topic very important as far as modern day meteorological conditions are concerned. No, so you might have known about the normal lapse rate, right? Normal lapse rate or atmospheric lapse rate. But under some unusual circumstances, there may be the atmospheric condition that prevails over a region, over a locality for a short period of duration called thermal inversion, no, or negative lapse rate or reverse lapse rate. No, lapse rate in the sense, normal lapse rate in the sense whereby temperature reduces with the increasing altitude in the lower layer of atmosphere. No, when you take this as a ground and this as a lower layer of atmosphere, whereby temperature lapses, no, with increasing altitude, it is a normal one, no, that can be found in the tropospheric layer of atmosphere. No, under unusual circumstances, in the sense, no, somewhere, no, the ground become intensively cold ground, or somewhere existing air, no, the air that is found in situ is replaced with some invading air. Under these conditions, no, a peculiar atmospheric phenomena that goes on, no, called temperature inversion or negative lapse rate. Now we can move on to the complete description about the negative lapse rate or inversion of temperature. Now, so this there are certain conditions. There are certain preconditions that must be met by the prevailing atmosphere so that the temperature inversion would be the associated phenomena. Now that we can see, let us discuss those conditions one by one. No, so see, when you um, so this is about the fundamental description about inversion of temperature, no, where temperature increases with increasing altitude, no, called thermal inversion. It is also called negative lapse rate or reverse lapse rate. Now the temperature inversion usually prevails within a locality for a shorter duration of time. No, it is not a regional phenomena, rather than it is a localized phenomena for a shorter duration of time, no, within a limited layer of a limited column of tropospheric layer of atmosphere. No, so let us talk about the conditions one by one. No, if any region, any locality where the winter is long, that means night is long winter night, then where the ground, no, the underlying ground would have become intensively cold. This cold ground in turn cools the air from below. No, so when the air is cooled from below intensively, the lowermost layer of atmosphere that comes, that is found very proximity to the ground, must be very cold air. No, this layer of air must be very cold layer. Then this must be cool air, this must be warm air, then warmer air. Now this is a way temperature increases with the increasing altitude. Now this is one way through which thermal inversion may happen within the lower layer of atmosphere. The second condition, no, if at all, no, any region where atmospherically high pressure prevails, then the cloud, no, the sky must be devoid of cloud. No, then the sky is clear sky, cloudless sky. No, then the earth would have cooled radiationally very intensively. No, so that no, earth becomes intensive cold, the land become intensive cold, the cold ground again cools the air from below, and the atmospheric column exhibits thermal inversion. Now next one, calm and stable air condition. No, there should not be any high velocity wind. If at all, no, there is a high velocity wind, then the above lying layer, the layer of atmosphere which is found very proximity to the ground, no, would not gain the sufficiently colder temperature from the ground. No, that means whatever the air that is found in situ must be a stable air, calm air condition should prevail. No, there should not be any cyclonic condition, any atmospherically tumultuous condition. No, that should not prevail in that particular region. No, if at all such conditions found in the particular region, then the region would never exhibit thermal inversion. No, then the region, no, would be occupied with the dry air. If at all the air is laden with some moisture, then it should have gained the capacity to trap the high heat. No, if it is having the tendency to trap the heat, no, air would never be cooled. Air remains warm. The lower layer of air remains warm. Then the atmosphere, no, would never exhibit the thermal inversion. Again, there should be a slow movement of air. There should not be any tumultuous atmospheric condition or high velocity wind that should not prevail in that particular region. No, so there should be a very large scale wind movement, but imperceptibly slow movement of air must be found in that particular region. Now then there should be a snow covered, there may be a snow covered ground, or the cold ground, or the frozen ground that is responsible for cooling the air from below, so that the air can exhibit the thermal inversion. Now these are all the conditions which are responsible for the genesis of temperature inversion or the formation of thermal inversion in the lower layer of atmosphere, right? So then we can talk about various types of inversion any atmosphere that can exhibit. No, so one type of thermal inversion called non-advective inversion. No, another type called advectional inversion. Advection in the sense, no, advection in the sense it is a method, no, it is a method through which heat would be transmitted horizontally from one region to another region. That means here it means that whereby air column, air layer which is having the tendency to move horizontally, so that temperature and the degree of hotness of the air would be transmitted from one region to another region. No, so in that way, no, thermal inversion would be triggered within the lower layer of atmosphere. No, non-advectional in the sense, no, one is called ground inversion, another one is called upper air inversion. No, these two are categorized as non-advectional inversion, whereby air movement may not be found, rather air moves either vertically or the air that is found in the terrain in situ would exhibit thermal inversion. That means ground inversion. No, so if you take a cold ground, no, if at all, no, the Bangalore terrain, no, it had cooled intensively during winter night. No, that ground is more than enough to cool the air from below, so that that atmosphere that found proximity to the ground exhibits thermal inversion. That means the air in situ on the cold ground exhibits thermal inversion. Then it is one kind of one form of non-advectional inversion. No, so another form in the sense upper air inversion. No, that means when you take an atmosphere, no, that can be found at the altitudinal extent of 4 kilometers. No, so you imagine the atmosphere that is found far beyond 4 kilometers. No, let me take one limb of air current that subsides from 5 kilometers to 4 kilometers. When any air current, any mass of air that subsides from one altitude to another altitude, it is having the tendency to undergo thermal contraction. When the air undergoes thermal contraction, where heat would be gained, that means the subsiding air would be warmed adiabatically. When the air is warmed, no, the warm air form a layer, a thermal layer. No, so that layer, no, must be the thermal layer. Then the underlying layer must be cool air. No, thermally warmer layer is found at the mid. No, beneath that you can find the cold layer. No, above that you can find the cold layer. But when you measure the temperature across this layer, whereby temperature increases with the increasing altitude, now that can also be found at the higher elevations of tropospheric column of atmosphere, called upper air inversion. It is also one kind of non-advectional inversion. No, so then when you come to advectional inversion, whereby horizontal movement of air must be there. No, either horizontal movement or some slanting movement of air must be there. That means one set of air, one parcel of air that must be transmigrated from one region to another region, so that that causes, that triggers the thermal inversion. For example, if you take frontal or cyclonic inversion, whereby if you might have known about front. Front in the sense it is a zone, it is a transitional zone where cold air meets with the warm air. So this must be the cold air, this must be the warm air. Let me interpret it you pictorially. So you see that no see that it must be the frontal inversion. Frontal inversion. Where this must be the cold air. This is front. This is front in the sense it is a transitional zone. It is a gently sloping transitional zone that is formed because of convergence of cold air and warm air. So two air having different temperature, different in terms of temperature, in terms of atmospheric pressure, in terms of humidity. So and so physical properties, if any two air component meet themselves, that paves the way for genesis of a gently sloping transitional zone called front. It may be warm front or cold front, whatever the front may be. Where the cold air, underlying air. Even if you take a cold front, cold front can be denotified in this form. So here also, it must be a cold air and this must be warm air. In either of the cases, you can find cold air beneath and above which you can find a warmer layer of air. This warmer layer of air must be laden with moisture. This warmer layer must be cooled from below. When it is cooled from below, so the lowermost layer must be cold layer, then cool layer, then warmer layer, then warm layer, then warmer layer, whereby temperature increases with increasing altitude. In that case, so any front, associated atmospheric phenomena whereby temperature increases with the increasing altitude, then that thermal inversion must be the frontal inversion. So in that way, we can talk about another type of inversion, like valley inversion. Valley inversion in the sense whereby this is an inversion that is accompanied with some valleys, whereby you can find some highlands and the bottom of the valley. So when during long winter night, the top of the valley or highland of the valley, that would be cooled intensively. Cooled intensively. When the top of the valley is cooled intensively, and the air that is in situ must be very cold air. So this cold air becomes a dense air. This dense air is having the tendency to transmigrate from uphill slope to downhill slope. So whatever the air, that must be the comparatively warmer air that might be replaced when this cold air drains into the bottom of the valley. So that warmer layer of air would be uplifted and the colder layer of air infills the bottom of the valley. In that case, no, bottom of the valley is infilled with cold air, above which comparatively warmer layer of air is found. If you measure the temperature again increases with increasing altitude within the valley. No, so this inversion is called valley inversion. No, again, no, so this is a way we can find all types of inversion, like some of the inversion, like surface inversion and subsidence or upper air inversion, all can be categorized as non-advectional inversion, valley inversion, and frontal inversion, as well as marine inversion. Somewhere, if you take Marina Beach, so where Chennai plain is found, this is a Marina coast, where from the ocean, from the sea, warm and moisture that would have invaded towards the cold Chennai plain during winter. So when it is night, comparative warm and moisture which invades this cold terrain, the already existing cold air would be replaced and the warm air occupies this region. Now this region is occupied with the warm air. This warm air would be cooled from below, so that the lowermost layer must be cold air, then cool air, then warm air, then warmer layer, whereby temperature again increases with increasing altitude within Chennai plain. This kind of inversion can also be found in the plain which is found very proximity to the coast. So this is called marine inversion. So this is a way we can talk about all types of inversion that can be found within the limited space of lower layer of atmosphere for a particular point of time. So then we can talk about the effects the effects that are being triggered by thermal inversion. That means what are the impacts that are being accompanied with the emergence of with the genesis of thermal inversion in a particular locality. So this is very important. This is what the content associated with applied climatology. It is very important as far as modern day meteorological conditions are concerned. So that means whenever you notice this, the region which exhibits thermal inversion must be accompanied with one most important phenomena called fog. So see, whatever the inversion may be, whether it is a ground inversion or marine inversion or frontal inversion or valley inversion, whatever the inversion might be. So for example, if you take marine inversion, the warm and moisture which invades towards the cold ground, where the invading warm and moisture would be cooled from below, so that the lowermost layer become colder air. This colder air, where the moisture present in the colder air undergoes condensation, the condensed form of water vapor turned into cloud. So cloud is nothing but an accumulation of microscopically tiny water droplet. Such a cloud that is found very proximity to the ground, then it is called fog. So fog, in the sense, there is a way we can define fog. Fog is the most important atmospheric phenomena or weather phenomena accompanied with the inversion of temperature. So then because of degree of coldness, damage of crops, fog a fog that forms in the very cold region like Shimla or Kangra Valley or Kulu Valley or some Sangla Valley, so where apple orchards or coffee plantation or tea plantations may be found. So when such a fog forms under the region that exhibits sub-zero temperature, then the water droplets that can be found within the fog would have undergone frozen form. Nothing but frozen water droplet water droplet that can be found within a fog. No, so this frozen water droplet is called frost. No, so frost is nothing but frozen dew is called frost. This frost is highly detrimental for the tender leaves that are being emanated from either tea or coffee or apple. No, so crops that are being cultivated over the valley slopes. No, where frost would be the most important detrimental factor. No, so again, the vegetation would be affected. No, that means, like apple orchards, that are being avoided at the bottom of the valley because of the very frequent frost attack that is being triggered by very frequent thermal inversion. No, so and no, sometimes, when any region, if you take Chennai city or Bangalore city or Mumbai city, where fog is the condition associated with the thermal inversion, then that would be the hindrance for navigation, air navigation or some surface navigation. No, so these are all the effects, for because of some beneficial effects that can also be accrued out of fog or thermal inversion. No, for example, if you take Yemen Hills, you might have heard about a nation, called Yemen. No, Yemen, where you can find Yemen Hills. Yemen Hills are cultivated with some coffee, a peculiar coffee called mocha coffee. These coffee plantations thrive a lot over Yemen Hills. So even though the Yemen region or Saudi Arabian region, which are laid under scorching heat, region of scorching heat, where the crops, the tender leaves of these plantations would be protected because of the existence of fog. No, because of the formation of fog, these coffee plantations are protected from the scorching heat that pervades over the region. No, this is a way, we can talk about the some deleterious and beneficial effects that are being found associated with thermal inversion. No, so again, so this is a way, we can come to conclude about the thermal inversion. It is a very important topic, the easiest topic, among the easiest topic among all. So again, it is an important topic because it is well known as far as modern meteorological conditions, modern atmospherical conditions are concerned. So having tremendous implications, as far as present day meteorology is concerned. So this is a way, we can conclude about the definitional context of thermal inversion, then the conditions favorable for thermal inversion, then types of thermal inversion, and the region accompanied, a region which very often exhibits thermal inversion, and some of the beneficial and deleterious effects that are being triggered by thermal inversion. All can be concluded. Okay, so thank you so much, friends.